is what is analytics all about, how does one go about solving problems, what it means to solve problems in analytics, and how is this program going to help you achieve that. I'm going to give you a very brief rundown on the various things on the program, the various modules which we have designed, how we plan to cover some of the domains in the module, and as well as the things which we cover and what's the optimum way to get the maximum out of the program. There are 4 basic stages when we are trying to solve any problem in analytics. The first stage is always the problem formulation. The second stage is the data gathering linked to the problem formulation. The third stage is where we do the data analysis, and in the last stage we try and figure out how to implement whatever solutions which we propose. The problem formulation, I think, is probably the most important part of all the 3, and that's partly because that's the portion which we are not going to do in this program, because that's the portion which we don't think we can do in any program. Problem formulation will typically start with a brief which either the client is going to give or something which you will propose for the client. So let me kind of therefore give a very brief backdrop of the 3 types of analytics firms which we see in India and also outside of India, which I'm going to classify them are the captive analytics firms. For example, American Express, they were the first ones to be doing analytics in this country or even globally, and they have a very strong analytics team. And they don't do analytics for any other clients, they're only doing it for American Express, who is their client. Now, the kind of challenges they face is very different from the kind of challenges which other analytics firms faces. For example, the problem formulation for the American Express as an analytics client, analytics firm is not very challenging or is not very difficult, in the sense that they have a well-defined business line and they are trying to get better and better at it. The challenge for them, however, is that a lot has been done. The improvements can at the best be marginal, and yet one has to improve. So that's one type of firms which I call the captive analytics firm. There are second type of analytics firms which are not captive, but they have a lot of clients and they are trying to solve their problems. I would definitely put firms like eValueServe or maybe Mu Sigmas or even Mu Sigmas in that category, who do not have any captive clients, but they do pitch for clients and they try to solve their problems. And for them, the problem formulation is very important, because the client will come up with a problem which is very loosely unstructured. It could be as simple as increase my sales, or make sure that if I send a million mailers, I get a good response rate. These firms have to primarily spend time, how do I convert this unstructured problem to a solvable way? That's the second kind of firm. The third kind of firms are probably the ones who are definitely doing much more challenging, and those are the ones whom we read about and aspire to be. They don't have a captive client. In fact, they don't have clients, but they kind of develop products, and once they have developed the products, they go and hit the market, and then they find clients who would be willing to associate with their product. Now, the reason I am making a distinction between these 3 firms or 3 types of analytics firms are, for the first group, the problem is already well defined. You are trying to get better in how to solve it. For the second group, the client is well defined. The client knows the problem very well, but the client may not be able to formulate the problem the way you want it, and therefore the challenge for you is to be able to formulate that and ensure that your data science team can work on it. For the third group, there is no client, there is no captive audience, there are no captive clients, and therefore what you are trying to do is you are trying to think or anticipate that what could be an excellent product and where can it be used, and then your data science team is basically working on that product. The problem formulation is something Something, where do you learn? My simple answer is you don't learn it anywhere. You keep your ears and eyes open, you read as much as you can, you figure out how do people solve some problems, what kind of data do they use, and you just get better at it. I don't think we can have any structured program which teaches you how does one formulate problems and solve it. What we can do, or what we end up doing in any structured program, are the second two stages. One is the data gathering part, and the other is the analysis of that. So let me give a brief about what does data gathering mean in the analytics industry. When we are doing data gathering, traditionally there would be two types of data which we would be using. One would be the primary data, and the second would be the secondary data. The primary data is one where you would go do survey. There is no data available. You just generate the data by asking questions. It could be a structured questionnaire. It could be a unstructured questionnaire. But essentially what you're trying to find out is gathering as much of information, and then try to figure out what to do with that information. For example, you want to find out if there are if there is a car model which is available in 4 color types: red, blue, black, and white, and you want to find out what kind of colors do people prefer. What you do is you do a large part of market survey, and you just ask them what kind of colors car do you prefer, and just try to do a socio-demographic mapping to say, these are the type of people who would prefer this kind of color. So that would be primary data collection. The second type of data collection would be what is the secondary data, or the transaction data. Now, if I look at the same problem, and if I want to find out that what kind of colored card do people like, if I'm working with secondary data, I don't actually go and ask people what kind of colored card do you like. Instead, what I do is I just find out the percentage of cards with different colors being sold and what kind of people are buying them. And because people have transacted or revealed what they have done, I'm going to use that data to infer maybe people from this particular background are more likely to buy this kind of card. Now, obviously, these are the two traditional ways when we looked at analytics. The challenge for the first one was essentially that the collecting the data is a huge problem. It's time consuming, it's costly, and especially which we are doing if we are trying to do in a country which is as diverse as India. By the time you start collecting your data and by the time you finish, so many things would have changed that the data collected in the first phase may not be relevant at all by the time you finish the study. This is leaving aside the cost of collecting and the cost of administering the questionnaire and the other costs associated with that. But the advantage is that you could virtually get any information which you want because you are the one who is going to create the data. When it comes to the secondary data, the advantage again of secondary data is that obviously it is far less costly. You don't have to go and visit places or small units to collect the data. The data is usually in a very relatively what we call a clean form. But again, the problem with the secondary data is that your analysis is going to be limited to the fields on which the data was gathered, because you are not the one who is collecting the data, and therefore you have no flexibility in trying to get new information which is not there in the data. Now, where does analytics fit in all of this? Honestly, to do the secondary data and the primary data, we don't need a whole lot of analytics or the kind of program that we have signed up for. Where we actually use a lot of analytics is to use a third type of data, and which is neither the primary nor the secondary, and those are the unusual sources of data. Where the data is not collected by asking somebody, the data is not being generated through any transactions. It is certainly observing through various unstructured format. maybe satellite images, maybe voice patterns, maybe pictorial images or videos, or sensors giving some data. So now these are the, I mean, these are the unusual sources of data which people kind of use to solve problems which are traditional, certainly. Also problems which one could not have thought about solving traditionally, because the kind of data that was required was no longer there. So one of the major contributions of analytics is not only the tools and techniques they use, but also the unusual and the new sources of data which people use, and then and they try to do the analysis based on that. Now, in this program, of course, we will be doing some amount of unusual data, but what we will be focusing primarily on is on the analysis once the data is kind of there. And I'm going to talk about in a lot of details about the data analysis, that what are the various modules which we have broken the program into, and what goes in each of the module, what are the kind of domain expertise which we plan to incorporate, and at the end of the module, what are the things you are supposed to be good at, and what are the things which you are supposed to be able to do. That's what I'm going to talk about. The final thing in the analytics journey is implementing your solution. This is an important point in an analytics exercise, and this is what it distincts it from a pure research work or a pure research output. When we do a pure research output, the kind of techniques which we use are probably even more quote unquote deeper than what we do in a typical analytics domain. But we are never worried about the research output, how is it going to look like, or how is it going to be useful. In other words, the same problem when we do from a research point of view, the output is usually maybe 20 pages paper with a lot of complex equations, nicely typed in Times Roman 12 font, and that's it. Maybe spiral bound for good effect. But when we are solving a problem in analytics, that's not how your client would want to see the output. The client would want to see eventually something which is visually very appealing, probably as a software code which can be run in the system and will generate output, or maybe an app. So the implementation is an extremely important part in an analytics solution. Now, in this program, however, we are not going to talk about implementation, because implementation is not so much about the data analysis or analytics techniques per se. It is more about the coding, it's more about the computer science or developing apps. So that's the part which we are not going to focus on this program. But I want you to keep this in mind, that whatever analysis or results which we get, eventually you must keep in mind that once I've done that, how am I going to implement it for the client or for anywhere? Move on to the data analysis part, and let's see how do we plan the 6 months ahead. When we do data analysis, we would like to categorize into two distinct I won't say zones, two distinct types. One is we need to understand and appreciate the data which we have, and based on that, we need to be able to predict whatever we want to predict. Now, when I'm looking at understanding the data, obviously, whenever you're predicting something, it will be based on some data. Understanding the data would form an integral part, and the kind of things which we need to understand the current data would be, we need to be able to make good visual representation, because the kind of insights one gets with simple charts, simple bar diagrams, and scatter plots, those are extremely important. Now, when we are looking at the data, we have variables, variables that we want to predict, and we also have variables which we want to use to predict something. So essentially, we are looking at two things now. We are looking at what is called univariate analysis. Univariate analysis would be looking at a particular variable in itself and trying to find out on an average how does that variable behave. Is it kind of bunched towards a particular number, or is it kind of very spread out? Does it have some obvious properties which we can exploit? And those are the kind of things which we do in the univariate analysis. What we also want to do in understanding the data is we also need to do what is called the multivariate analysis. And in a typical multivariate analysis, we are looking at the relationship between multiple variables. We are trying to find out if a particular variable is kind of explaining, causing something else to happen, or is being caused by something else to happen. And these are the things which we need to be able to understand the past or understand the data. When it comes to predicting the future, there are two strands which we should be wary of. One is the kind of prediction which is sensitive to time, and those are typically the time series analysis. And the other kind of predictions are which are not sensitive to time, what we can call time invariant. Now, what are the broad difference between the two? Predictions which are time sensitive, by that what we mean is what we predict the particular value to be on a Tuesday should be different if the date changes from Tuesday to a Wednesday. If that's the kind of thing, we are looking at a time series analysis. The stock market would be an excellent example of that. That the stock price which you are going to predict for tomorrow will be different from what you predict or what you're going to predict the stock price maybe 5 days from now. So therefore, the time is a very important part in this kind of analysis, and we have to factor and account for that. For things which are time invariant, of course, we are predicting things in the future, but there, whether we make the prediction for a Tuesday or prediction for a Wednesday should not make any difference. To give an example, if you're trying to predict among all the guys who are going to borrow, or among all the mailers which we are going to send, how many of them are going to default in the first example, or how many of the guys who got the mails is going to respond in the second example, I don't think there is any reason to believe that the numbers will be different from Tuesdays to a Thursday, right? And therefore, these are time invariant ones. Now, what we will be doing in this program is we are going to look at the time series part, but largely focus on the time invariant predictions, because large part of analytics which we do also uses a lot of time invariant prediction. Now, within the class of time invariant predictions, I would again further subdivide into two branches. The first branch is called the unsupervised learning. The second branch is called the supervised learning. What's the distinction between the two? Well, in an unsupervised learning, there isn't a final outcome against which you can cross-check how accurate you are. Some of you might have heard about the term clustering. I'll talk about it a little bit, and you're going to learn about a whole lot of clustering in the program. But let me give you an example that if you have a large number of data, you can divide them into 3 or 4 clusters. And what it basically means is you're going to bunch the data into similar types and call it a cluster. Now, the cluster which you form, how good or how accurate they are, that question doesn't make any sense, because there is no natural cluster against whom which you can cross-check and say, this observation doesn't belong to cluster A but belongs to cluster B and I have wrongly classified into cluster A. There is nothing against which you can cross-check, and therefore it's what we call an unsupervised learning. Supervised learning, on the other side, on the other hand, is where there is something against which you can cross-check. For example, if I'm trying to develop a model which predicts the defaulters from the good guys, the good borrowers, once I have classified the data into the defaulters and not defaulters, I can actually cross-check with the observations whether they actually defaulted or not defaulted. So to make it very simple, in an unsupervised learning, there is nothing to cross-check, but still we do a lot to kind of get better. And in fact, in a lot of artificial intelligence which we do is based on unsupervised learning. Whereas in supervised learning, we are much more focused. We actually get there very directly, and we can cross-check and say, look, what we have predicted, how close it is to the actual, or how different is it from the actual. Now, in this program, we are going to cover the supervised as well as the unsupervised learning. We are going to do the understanding the data. We are going to do the time series. We're going to do the cross-section. And what I'm going to take you to next is how do we cover each one of them in the modules to come. Welcome back. So I had a coffee break. So I'm hoping that some of you also had a coffee break, because what I'm going to now get into is the nitty-gritties of the various modules which we have, and all the things which we have talked about in terms of the kind of data gathering or the kind of data analysis, understanding the past, the supervised, unsupervised learning, time series, etc., and how do we plan to cover them in each of the modules. Now, one thing which we are planning to do, we don't want to treat analytics as just a subject or a set of subjects put together to develop the technical skills. So that means that whenever we do discuss a set of problems, to the extent possible, we will try to do it with a particular domain, so that we understand the problem in plain English. How does one solve it, and then use the various techniques to kind of solve those problems. Instead, so what we are going to do is, this program has 6 modules, and in the 6 modules, we are also going to pick up different domains. There are going to be modules where we are going to primarily focus on marketing and retail analytics. There are going to be modules where we are going to primarily focus on finance and risk analytics. There are modules where we are going to look at some policy analytics. There are modules where we are going to look at health analytics. There are modules where we are going to look at some of the supply chain and logistics analytics. So in other words, each of the modules, whatever techniques which we learn, we are not going to learn them in silos. We are not going to learn them to only learn how to use a particular technique. We should be doing it in a context, and the context is a set of subjects which we have for that. Now, what you can see in front of you is there are 6 modules, and these modules are called Introduction to Analytics, Fundamentals of Business Statistics, we have Advanced Statistics, we have Data Mining, we have Predictive Modeling, and the last module is the Time Series Forecasting. What we will try, and in every module, we'll start with an introduction, we'll talk about the basic concepts, we'll use a data set to be able to be hands-on on the concept, and there will be some assessments in the module. Assessments will be weekly, so that there is a continuous learning which you have in this module. And towards the end of the module, we will have a mini project, and that usually will be based on a data set from a slightly different domain. And in the next module, we'll be using that domain. So, for example, if we look at, let's say, data mining, we are going to use the domain which we are going to use in data mining is marketing and retail analytics. So you are going to learn all the techniques in data mining using marketing and retail analytics. But towards the end of the module, when you are about to do the mini project, you will be given a different data set. You will be introduced to a different data set. So the data mining will be mostly done with marketing and retail analytics, but towards the end, we'll be using the finance data. The data will be explained. You will be applying the tools and techniques which you learned in the data mining on that. Score your marks, do well, remain motivated, and then when you come next month for the predictive modeling, all the techniques which we learn in predictive modeling will be in the context of that data set, in other words, in the context of finance. Again, when we are about to end that predictive modeling domain, will follow the same kind of thing which we did earlier. There is going to be a new data set introduced, and this time it's going to be most likely on supply chain and logistics analytics. You'll have a data set, and then we're going to use that for the next module, which is the time series forecasting. So that's the way we are going to, we have planned it so that you get an exposure to the tools and techniques, as well as you have a fairly good idea about the understanding of the domain. The 6 modules which I talked about, Introduction to Analytics is a standalone. The next 2 modules, Fundamental to Business Statistics and the Advanced Statistics, are basically understanding the data, the way if you have looked at the slicing which I have done earlier. The time series forecasting is looking ahead, and which is a time series component which I explained earlier. And the 2 modules which is on data mining and predictive modeling is also in predictive analytics, but this is the time invariant predictive modeling, predicting the future part. So now let's kind of pick up each of the things which we have. So let me start with the module 1, which is the Introduction to Analytics. Now, the Introduction to Analytics is where you are going to get the analytics landscape, and large part of this current lecture is on that. The major focus of Introduction to Analytics happens to be the introduction or using analytics, getting started with R. There are 2 basic softwares which we are going to use. We have to be comfortable in Excel, because that is still the primary preferred form of data which can actually do a lot of stuff. And it's always good to be hands-on on Excel, and you have to be comfortable in Excel, because one of the great things about doing things in Excel is that you have to understand the logic and intuition a little bit, because there are very few commands in Excel which you can use, and therefore you will have to be aware of what's going on the back end. So that kind of helps you understand the data and the algorithms better. So we are going to use a whole lot of Excel, and then what we are going to do is we are going to move to R. I'm sure most of you who are into analytics or have some interest in analytics know that R is probably now the gold standard, because it's an user defined, it's a freeware software. It is continuously evolving. It can handle a reasonably good amount of data. It requires some moderate amount of programming skill, and it can actually talk to or communicate to various kinds of data, import them and use them in the particular structure. In fact, one of the big advantage in R is what you're going to get very early on in the project, because here you're going to know how to kind of import data, the usual structured data, and you will also know how to kind of look at some of the unstructured data. In other words, right in the first module, when you are playing around with R, you will be taught, you will be exposed to how to pick up unstructured data, which is typically a text data, which is not a integer or a quantitative data. How does one import an text data? How does one analyze a text data? How does one convert a text data to a quant data? And once you have converted the text data to a quant data, then you are all set to kind of work on that data, because analytics will be eventually working on a quantifiable data. So the various weeks which we have in the Introduction to Analytics will basically be looking at R, helping you how to install R, basic commands in R, basic operations in R, some very, very basic data cleaning in R. And this is an important part, because when you guys start your career in analytics, all the fancy things which you will be taught will be learned, or which you will be allowed to do that only after maybe 2 years. Initially, you will be spending a lot of time cleaning the data, understanding the data, be patient with the data, getting new patterns from the data, and this is the part which you will have to do. This will require burning some midnight oil, and I'm sure you are willing to put in that hard work. And we will be aiding and helping you in our what are the kind of things which we can do. So at the end of the first module, you will have a fairly good idea about two things. How does one use R, and how does one prepare the data from a structured or from an unstructured source, which is kind of ready to analyze. Once we have done that, we move to the next module where we will be basically looking at understanding the data, which is the fundamental of business statistics. Okay, so now let's kind of move to the fundamentals of business statistics and what we plan to cover there. As we discussed, this will basically be looking at two things. It's going to look at an univariate analysis. It's going to look at a bivariate analysis. Now, we are trying to understand the data, so we need to understand for a particular variable, how is the data behaving, and we also need to find out that between two variables, how is the data related. So the broad topics which we are going to cover there, we are going to look at measures of central tendency, and basically you will be learning the mean, the median, the mode. You'll be learning about the measures of dispersion in terms of the variance and standard deviation. You are going to learn about the correlations, which basically looking at the relationship between two variables. You are going to look at the things in terms of some visual plots, in terms of histograms, which will give you how close the data is, how bunched it is or how separate it is. You are going to look at scatter plots. Scatter plots will give you how is X and Y related. So these are the kind of things which we'll learn in the fundamentals of statistics. And then there is an important part which we will have to also figure out in this module, which is that eventually when we are doing a prediction, we can never be completely accurate. There will be some error. So we need to be able to figure out how does one minimize the error. What do you understand by the error? How does one minimize the error? Whenever we are predicting, we also therefore need to figure out that what is the chance of getting it right, and we need to therefore understand the basic concepts of probability. So in this module, you will also be exposed to the basic concepts of probability. You will learn some of the discrete probability functions, and you will also learn about some of the continuous probability functions in terms of, you will be learning about normal distribution. You will be learning about binomial distribution. So basically, you are going to look at how does the probability of something happening, and so that you can say that this is the probability of getting a prediction accurate. The final part in this module is where we will be learning how to make a statement and being able to prove. So for example, we can say that people of a particular type are more likely to default than people of a different particular type. Now, if we have to say that, we need to be able to compare the averages of the two. We should be able to say something about the mean. We should be able to say that whether this group is higher than that group or not. And we should be able to say that statistically. So the final part of this is where we are going to look at what we call the hypothesis testing. We will be doing a one sample testing where, and we will also be doing a two sample testing. So basically trying to say that between these two groups, whether the average of the first group is higher than the second, whether the variance of the first group is higher than the second, so that we are able to compare single or multiple variables in the data set. Now, these are essential parts in getting the fundamentals right eventually when we do the prediction. So we need to understand the data in terms of how well it is behaved, and that's the central tendencies, how well also the visual aids in terms of the histogram and scatter plot. We need to be able to figure out the basic concepts of probability, because eventually whatever we predict can't be predicted with certainty. Because there is an uncertainty involved, we must understand, break the components into probability, and therefore we will be picking up or looking at the probabilities. And finally, we should be able to make some inference about samples, inference about populations, inference about two groups. And because we have to make inferences, we need to be able to be comfortable with the language of hypothesis testing. That's going to be your second month on the second module. Once we have done that, we will move to a third module, and that is somewhat related, but there are also a few things which we have to do to actually make a better sense and getting closer towards and that would be the module on advanced statistics. Now, in advanced statistics, three important things which you are going to learn. You will start with basics of regression. Please remember that regression is perhaps the single most important concept which you are going to learn in the analytics module. I won't be wrong if I said that there are a lot of things which you are going to learn, and if you are even not comfortable in some, maybe it's okay. But but in regression you have to be comfortable. So that's something which you cannot compromise. And regression is basically when you are trying to find out how does a set of variables x1, x2, xn affect another variable y? How are they related? How best can you establish relationship? And this is the backbone of any kind of prediction. A lot of advanced predictive modeling techniques are at the back end based on regression. So we are going to start with very simple regression, and you will learn what's called the simple linear regression. You will also be doing multiple regression. And you will be learning regression not so much to do a predictive modeling right now. We will be doing regression later on again because it's such an important topic. You will learn regression to do some of the other important things, and one of them is what we call the ANOVA, which is the analysis of variance. Now, if I have to make a distinction between ANOVA and hypothesis testing, because both of them are doing very similar things, what would suffice is in hypothesis testing, you can at best compare means of two samples. For example, you might be looking at whether the average marks of, or let's say the average income of guys who have not finished school is less than average income of guys who have finished school, right? So if you have to compare just these two samples, you'll be doing hypothesis testing with two samples. In ANOVA, we go one step further, where we can actually compare the average income of multiple groups. So in the same context, an appropriate example would be if you're trying to cover, compare the average income of guys who did not complete school with people who completed school but did not complete college, and third group of people who have completed college. So if you want to compare the mean income of these three groups, what you're going to do is an ANOVA technique. You're going to learn the ANOVA techniques in this particular module, and that's again a very important thing for predictive modeling, because eventually when we are trying to figure out which are the important variables for prediction, ANOVA is a very, very handy, simple way of being able to fix that. The third thing which you're going to learn in this module is, which I can broadly categorize as a dimension reduction problem or a dimension reduction issue. Now, let me try to give an overview of what I'm trying to say. Most of us talk about big data, and now big data has a lot of components. I don't want to specifically talk about big data. I want to talk about the cases where the data is big. Now, there is a distinction between the two. For a big data, there has to be three things. The data has to be big. The data has to have a variety, so it can be multiple sources of structured or unstructured data, and the data has to have a velocity. It should come very fast. Now, I'm only talking about where the data is big. Now, if the data is big, typically it is big because you have lots of records. You have maybe 10 million transactions done on a credit card, and you probably have 100 fields. So you're basically looking at a data size which is 10 million cross 100. Now, working on the data can become very cumbersome, and you might not be able to get anywhere. Now, one of the things people do is to see if I can reduce instead of 100 fields, can I reduce those fields to a much smaller set, maybe 14 or 15? Then it becomes tractable. Now, how do I reduce from 100 to 14 or 15? The kind of techniques which we use is something which you're going to learn in this particular portion. You're going to learn about factor analysis, you're going to learn about principal component analysis, and these are extremely important to be able to combine variables to create a single variable, preserving the necessary features of the variables so that it becomes very handy when we are trying to do an analysis which especially involves a large dimensionality problem. Now, with these two modules of understanding the data, we would be in a good position to be able to now analyzing the data and learning the various algorithms of predictive modeling. And we're going to do that next. So the modules 4, 5, 6 are on data mining, predictive modeling, and the time series respectively. So let's start with data mining. So the next module is on data mining. Now, we have talked about supervised and unsupervised learning. We are going to start first with unsupervised learning. And apart from cluster analysis, which I had given a very brief overview of, we are also going to do association rules, which some of you might know it as market basket analysis. What we do there is, I'm sure many of you buy things from Amazon or Flipkart, and you often get to see the sticker that people who bought this also bought that. Now, this is basically what we do in the market basket analysis. We try to find out what are the kind of things which people buy together. It doesn't mean that if you buy A, you will buy B, but you try to only explain that A and B are bought together. So this is often helps in target, and that's what we will be doing in the market basket analysis as part of unsupervised learning. Now, if I come to supervised learning, I should be ideally making a distinction within the cross section, which means without any time playing any role, in two distinct kind of things. One is a continuous response model, and the second is a classification model. Now, a classification model or a classification algorithm is when we are trying to classify the observation into one group or the other, or maybe multiple finite groups. For example, we want to classify population into who is going to buy, who is not going to not buy, or who is going to default or not default. It could be just binary classification. It could be multi-classification. For example, we can classify individuals into who is going to buy a red car, a blue car, a black car, or a white car. So these are all classification techniques. And then there is another technique in the supervised learning which is called the continuous response model. Now in a continuous response model, we are not trying to predict whether you belong to one category or the other category. What you are trying to predict is a continuous value. For example, you're trying to predict what is going to be the GDP growth rate, okay? Or you're trying to predict what's going to be the marks obtained by a particular student, or what's going to be the sales forecast. So what you eventually predict is a continuous number. That's why we call it continuous response model. Okay. Now, in the data mining, we are going to primarily do the classification techniques, and we will use one of the most popular ones, which is the decision trees. Decision trees are an extremely important part of predictive analytics. We are going to learn the various things like the CART, the CHAID. Essentially, the idea behind decision trees is to find a set of rules that if this happens, then that is more likely to happen. So that's what we're going to do in decision trees. For example, we might end up saying that, if I have to predict who is going to default, I will go this route that if the person is above 50, then he will not default. But if the person is below 50, then if the person is male, then he is likely to default. And if the person is female, then she's not likely to default. So that's typically what a decision tree is. And that's what we will be learning in this portion. Developing on decision trees, what we will be doing is a very popular technique which is called the random forest. Now, if decision tree is a particular branch which we are trying to explore, what we can do is we can look at the data and we can randomly pick up sets of data or subsets of data, and then we can create multiple decision trees. Now, if a particular rule is a good rule, then it must appear in, if not all, but in most of the decision trees, right? So if the rule that if you're above 50, then you will not default, and if you're below 50, then if you're a male, you are going to default, and a female, you are not going to default, then this rule should be present in maximum number of trees which you have made out of the data. Now, how do we identify the trees? Purely randomly. The eventual analysis based on all this collection of random trees, because it's a collection of trees, we're going to call it a random forest. And we're going to learn how does one do a random forest. The third classification algorithm we're going to learn is what we call the linear discriminant analysis. Again, it is going to use a very, very simple technique. It's going to look at the data and say that, if the data can be partitioned into two groups or classified into two groups, then it must satisfy two important things. One, within a group, the data should be very close to each other. And across the group, the data should be very different from each other. So there has to be homogeneity within the group, and there has to be heterogeneity across the group. So what we'll be trying to do is we're going to probably draw a line which is going to separate the observations so that we can see the lines above the observations as a particular group, lines below the observations as another group. And that's what we do in terms of the linear discriminant analysis. Just like random forest is an advanced technique on decision trees, so does LDA or linear discriminant analysis, which is an advanced technique, and that's called the support vector machine, where we are probably going to look at a multiple kind of lines and try to figure out what is the best kind of line. The third one is a very simple algorithm which we are going to learn here. It's called the K nearest neighborhood classification. Let me explain what the KNN classification is. It's actually very simple and very intuitive. It doesn't require a lot of calculation. It doesn't require to calculate the variance or the covariance. It just goes like the following. That if I want to predict whether a particular individual is going to default on a loan, then I will identify the nearest neighbors of those individuals. Now, when I talk about the nearest neighbors, what I mean is I will identify 4 or 5 dimensions. I will create what is called a distance function. And on the basis of the distance function, I will try and find out who are his neighbors. And then I'll pick up odd number of neighbors, and you will see why odd number has to be picked up. And suppose I pick up only one nearest neighbor, which means that the person who is closest in terms of the distances. And if I find that person has defaulted, then I'm going to say this guy is going to default. And if I find that person has not defaulted, then I'm going to say this guy is not going to default. Now, obviously, one observation or one nearest neighbor is not a good idea. So what I will go is probably try 3 nearest neighbors. Now, if 3 nearest neighbors, then I will find out what's the majority rule. If 2 or more guys have defaulted, then it's fine. Then I'm going to assign default. And if it is not, then I'm going to say not default. So this is basically a very simple technique based on this distance function, followed by counting the neighbors and then finding out what is the majority going to do. Now, these are the things, the simple things which we are going to learn in the data mining. Apart from the unsupervised learning, with which we are going to begin the module, we are going to do these 3 these basic classification techniques in terms of decision trees, the random forest, the LDAs, these SVMs, and the K nearest neighborhood. What we will do next is, after we have done that, we'll get into the predictive modeling. Now, when we do the predictive modeling part, we are now going to revisit the regression all over again. And in this module, we are going to look at 2 important things. In fact, 3 to be precise. We are going to revisit the linear and nonlinear regression. So, and we will be doing that to do the predictive modeling, and that's the continuous response model, the linear regression. We'll do a nonlinear regression, which is basically the logistic regression, which I won't be surprised if all of you, or at least most of you, have probably know about logistic regression, because that's probably the mother of all algorithms, and that's something which is to be, we have to be very good at. So those are the regression-based techniques which we are going to do. So solve the continuous response model, which is the linear regression. Also solve the classification problem using the nonlinear regression or the logic model. We will now get into machine learning by doing the basic neural network, learn how to formulate the problem in neural network, how to solve it, and how to interpret it. And finally, in this module, what we are going to do is we are going to do a validation. Now, that's a very, very important part, because remember, what we are doing is we are not trying to find out what is the best algorithm. We are trying to find out what is the best approach to solve a problem. Now, in some cases, one algorithm might outperform others, but there is no guarantee that this is what is going to happen every time, everywhere. So we need to be able to compare the various algorithms and models. We need to answer that what are the key variables that is explaining an outcome. We may also require that if you have classified an observation into two groups, for every observation, what were the important variables? Why is this observation classified as a default or not default? What is it that this particular observation had, which the others did not have? Note, this is different from the question that what are the important variables. When I talk about what are the important variables that classify, this is on an average, that these are the important variables which had worked for most, but not for all. What I am trying to look at is, if I have identified somebody as going to be default, in fact, to give you a better actionable example, if you're predicting a illness or a medical ailment, there are two ways to look outperform others, but there is no guarantee that this is what is going to happen every time, everywhere. So we need to be able to compare the various algorithms and models. We need to answer that what are the key variables that is explaining an outcome. We may also require that if you have classified an observation into two groups, for every observation, what were the important variables? Why is this observation classified as a default or not default? What is it that this particular observation had, which the others did not have? Note, this is different from the question that what are the important variables. When I talk about what are the important variables that classify, this is on an average, that these are the important variables which had worked for most, but not for all. What I am trying to look at is, if I have identified somebody as going to be default, in fact, to give you a better actionable example, if you're predicting a illness or a medical ailment, there are two ways to look at the problem. What are the things which make a person sick, or I have a high fever? That's one part. The other question is, if a person has a high fever, what are the things that went wrong? So both are important for an actionable insight. So we have to learn this particular part. We will be learning the validation techniques in terms of, how do I play with the data, repeated sample. In particular, we will be doing what is called the k-fold validation. And this is a time where we will also doing, some kind of what we call an ensemble model, an integral part of machine learning techniques, by what is called the gradient boosting method, which is basically trying to improve upon the models by a little bit of incremental improvement. And the GBMs has been an extremely popular thing of late. And some of you who are probably eyeing some Kaggle competition, you will find out that a whole lot of people who finish in the leaderboard are using a lot of GBM. So that's the predictive modeling part. And in between the data mining and the predictive modeling, what we are doing is we are primarily doing classification techniques. We are doing continuous response. We are doing unsupervised learning, and all in the context of time invariant. So time isn't an important part. The data might have time component, but time doesn't play a role. The last module in the program is when we are going to do the time series part. Now, when we look at the time series part, we need to be very clear about two particular things when we are looking at time. One, where the time frequency is not very high. We are probably working with a weekly data or maybe a quarterly data. So essentially what we are more interested in is trying to find out the seasonality effect, the monthly effect, and we're going to learn various tools and techniques. How does one handle that? So it is really trying to forecast the seasonality part, those patterns, and getting it right. Very important for sales forecasting, very important for inventory planning, very important for supply chain logistics analytics. The second part of time series is where the data frequency is very high, daily, or probably if you're looking at stock prices, where you're not only looking at daily, you're looking at what we call the tick level data, which is the 5-second interval data, right? Now there, the high frequency data requires a different kind of technique, right? And we have to be able to, do some smoothing techniques. We need to be able to talk about what we call the random walk model. The random walk model is typically that we're unable to predict what's going to happen next in the next step, but nonetheless trying to get some idea how does one go about. So the time series module which we have, we'll have these two important parts: the high frequency data part, where you're going to learn the stationarity parts, the random walk models. We're going to learn about the ARIMA methods with the data. We're going to learn a lot about the data from how the data has behaved in the past. And we're also going to look at the forecasting using the seasonality. In particular, we're going to do some model like the winter halt model, etc. And this should be, and once you've done these 6 modules, what you should be confident in is identifying a problem, identifying the way to formulate it, identifying a way how to solve it, being able to pick up the right algorithm, being able to compare and compose, and maybe come up with a composite algorithm part, and being able to do a reasonably good classification problem, unsupervised learning problem, or maybe a continuous response model. Thank you. So I'm sure you're going to have a great time, and with some interactive videos, with some interactions. Hope to interact with you much more. Thank you once again.